Welcome to the deep dive. Today, we're going back in time, back to 2014,
Oh,
the year the Ethereum Whitepaper
yeah.
first hit the internet.
Wow.
It's fascinating to revisit this document. You know, it's like peering into a crystal ball. It's packed with these ideas that seemed so radical back then,
Right.
but they're shaping the world we live in today.
It really is remarkable. The white paper, it lays out the groundwork for a decentralized future,
Yeah,
not just for currency,
right.
but for a whole range of applications,
Yeah,
many of which we're just starting to see come to fruition now.
exactly. So for our deep dive today, let's explore this foundational document,
Okay.
the Ethereum Whitepaper, and unpack the concepts that are still so relevant even a decade later.
Sounds good. And remember, even if you're a seasoned crypto enthusiast, there's always something new to learn from revisiting the source material.
Absolutely. So let's start with the basics. The white paper kicks off by discussing blockchain technology,
Right.
which, as you know, is at the heart of both Bitcoin and Ethereum.
Right. And the paper uses the analogy of a traditional banking system's balance sheet.
Okay.
It's a shared record of transactions, but instead of being controlled by a central authority, like a bank,
Right.
it's maintained by a distributed network of computers.
So how does that work in practice? How do we ensure that everyone agrees on this shared record?
Yeah.
Especially when there's no central authority in charge.
That's where the concept of proof of work comes in.
Okay.
Think of it as a massive, decentralized puzzle-solving competition.
Okay.
Miners, which these computers on the network,
Right.
they're constantly racing to solve complex mathematical problems.
Oh, wow.
The first one to solve the puzzle gets to add a new block of transactions to the blockchain.
So it's like a constant race
Yeah.
with the reward for whoever solves the puzzle first.
Exactly.
But what prevents someone from manipulating the system or adding fraudulent transactions to the blockchain?
The brilliance of proof of work is that it makes it incredibly difficult and expensive
Okay.
for any single entity to gain control of the network.
Yeah.
To manipulate the system,
Right.
you'd have to control a majority of the computing power,
Yeah.
which is practically impossible, given the decentralized nature of the network.
That makes sense. It's like a system of checks and balances built into the very fabric of the blockchain.
Exactly. Now, the white paper also mentions this data structure called a Merkle tree.
Yes, that one sounded a bit intimidating at first.
Yeah.
Can you explain how Merkle trees play a role in this whole system?
They're essential for efficiently verifying data on the blockchain.
Okay.
Imagine a tree with branches,
Uh-huh.
each representing a chunk of data.
Right.
All these branches connect to a single root,
Okay.
which acts as a sort of digital fingerprint for the entire data set. This structure allows you to quickly verify whether a specific piece of data is included in the blockchain
Okay.
without having to download the entire thing.
So it's like a shortcut for verification.
Yes.
Especially useful for those who don't want to store the entire blockchain on their computer.
Precisely.
Yeah.
This is particularly important for light nodes,
Right.
which can participate in the network without needing to store the entire blockchain history.
Okay. So we've got this decentralized, secure system with a clever way to verify data. But the white paper doesn't just stop at explaining the basics of blockchain.
Right.
It goes on to explore the limitations of Bitcoin's scripting language
Mm-hmm.
for more complex applications.
Right. The paper highlights how developers were already experimenting with building on top of Bitcoin, even back in those early days.
Oh, wow.
You have examples like Namecoin,
Okay.
which aimed to create a decentralized domain name system,
Interesting.
and Colored Coins,
Okay.
which allowed people to represent digital assets on the Bitcoin blockchain.
So it was clear that the potential of blockchain extended beyond just cryptocurrency.
Absolutely.
Yeah.
But they were running into roadblocks because Bitcoin's scripting language wasn't designed for complex applications. It lacked the flexibility and power needed to create more sophisticated programs.
And that's where Ethereum steps in, offering a more robust and versatile platform.
Exactly. The white paper introduces Ethereum as a platform with a Turing-complete programming language,
Yeah.
meaning you can theoretically code almost any kind of logic into a program.
Wow.
And that program can live and run on the Ethereum blockchain.
This is where things start to get really interesting for me. This idea of a platform where you can create and execute any kind of program. I mean, it opens up a world of possibilities.
It really does. And the white paper dives right into this
Okay.
by introducing the concept of smart contracts.
Okay.
You could think of a smart contract as like a self-executing agreement
Right.
written in code that lives on the blockchain.
So instead of relying on a third party to enforce an agreement,
Yeah,
the code itself takes care of everything.
that's the idea. Let's say you want to create a simple contract where
Okay.
you agree to pay someone a certain amount of ether. When they complete a specific task,
Okay.
you can write this agreement into a smart contract,
Right.
deploy it on the Ethereum blockchain,
Yeah.
and the code will automatically release the payment
Wow.
once the task is completed and verified.
So it's like having an escrow service built right into the system,
Yeah,
but without the need for a trusted intermediary?
precisely.
Oh,
And because everything is transparent and recorded on the blockchain,
right.
you can be sure that the agreement will be executed as intended.
Now, the white paper distinguishes between different types of accounts on Ethereum.
Right.
Can you explain the difference between an externally owned account and a contract account?
An externally owned account is what you would typically think of as a user's account.
Okay.
It's controlled by a private key,
Right.
which is like a secret password that gives you access to your funds.
Okay.
A contract account, on the other hand, is controlled by the code of a smart contract.
Yeah. Okay.
It's like an automated agent
Right.
that can interact with other contracts and accounts on the network.
So it's like having these little computer programs running around on the blockchain, interacting with each other and carrying out their programmed instructions.
Exactly. And this opens up a whole new level of complexity and possibility.
You know, the white paper also spends quite a bit of time discussing messages and transactions.
Right.
What's the significance of those in the Ethereum ecosystem?
Messages and transactions are how information and value are transferred on the Ethereum network.
Okay.
A message is essentially a piece of data that can be sent from one account to another,
Right.
while a transaction is a specific type of message
Yeah.
that initiates a change of state on the blockchain.
Can you give an example of what you mean by a change of state?
Sure. Let's say you send some ether from your account to a friend's account.
Okay.
This transaction triggers a change of state on the blockchain,
Mm-hmm.
deducting the ether from your account and adding it to your friend's account.
Right.
This change is then recorded permanently on the blockchain.
Okay, that makes sense. Now, the white paper also mentions this concept of gas.
Right.
What is that?
Gas is a crucial mechanism in Ethereum
Okay.
that prevents abuse
Right.
and ensures that the network runs smoothly.
Right.
Every operation that happens on the Ethereum network,
Okay.
whether it's sending a transaction or executing a smart contract,
Right.
consumes a certain amount of gas.
So you have to pay for the computational effort required to execute these actions.
Yes, and this payment is made in ether.
Okay.
The sender of a transaction specifies the gas price they're willing to pay,
Right.
and miners prioritize transactions with higher gas prices.
Oh, okay.
This system ensures that only valuable computations happen on the network
Okay.
and prevents malicious actors from clogging it up with useless transactions.
It's a bit like paying a toll to use a highway,
Mm-hmm.
with the toll price fluctuating based on demand and congestion.
That's a good analogy.
Right.
And importantly, this gas mechanism also helps mitigate the risks
Okay.
associated with Ethereum's Turing-completeness. Remember, Turing-completeness means you can theoretically write code that runs forever,
Mm-hmm.
which could potentially lock up the network.
That sounds like a problem.
It would be, but the gas mechanism prevents this.
Okay.
Every transaction and smart contract has a predefined gas limit,
Right.
and if the code tries to exceed that limit,
Yeah.
the execution is halted
Okay.
and any changes are reverted.
So it's like a safety valve that prevents runaway programs from crashing the system?
Exactly.
Okay, that makes me feel a bit more secure.
Yeah.
Now, the white paper dives into a lot of detail about how the Ethereum state transition function works.
Right.
Can you explain that in a way that's easy to understand?
Essentially, the state transition function is what governs how the Ethereum blockchain evolves over time.
Okay.
It takes the current state of the blockchain,
Right.
which includes all the account balances and smart contract data,
Mm.
and applies a set of rules based on the transactions being processed.
So it's like a set of instructions.
Yeah.
That determines how the blockchain changes with each new block.
Precisely. And this function ensures that every change to the blockchain is deterministic and verifiable.
Okay.
Anyone can take the current state of the blockchain,
Right.
apply the state transition function to a set of transactions, and arrive at the same resulting state.
It's like a mathematical formula
Yeah.
that ensures the integrity and consistency of the blockchain.
Exactly.
Yeah.
And the white paper even provides a step-by-step example
Oh, wow.
of how this works for a simple contract,
Okay.
walking through the code execution and how gas fees are calculated.
Okay.
It's worth checking out if you want a deeper dive into the technical details.
Okay, maybe I'll save that for later.
Yeah.
Now, how does the Ethereum blockchain itself differ from Bitcoin's?
One key difference is that Ethereum blocks store not only the transactions,
Okay.
but also a snapshot of the most recent state
Mm-hmm.
of all accounts in smart contracts.
Right.
This state data is included in each block, which makes it much easier and faster to verify transactions.
So even though it seems less efficient to store more data in each block,
Right.
it actually makes the system faster and more scalable.
Exactly. You don't need to go back through the entire blockchain history to validate a transaction.
Right.
You only need the most recent state,
Okay.
which is included in the current block.
Okay, that's clever. And the white paper mentions something called a Patricia tree.
Yes.
What role does that play in managing this state data?
Patricia trees are another efficient data structure used in Ethereum
Okay.
to manage the state data.
Mm-hmm.
They allow for quick lookups and updates,
Okay.
which is essential for handling the ever-growing amount of information stored on the blockchain.
So it's like a highly optimized filing system that makes it easy to find and update information within the blockchain state.
You can think of it that way.
Yeah.
Now, all this technical complexity might seem overwhelming,
Yeah.
but it lays the groundwork for the amazing applications that Ethereum enables. That's what really makes it so exciting.
Right. And the white paper paints a pretty incredible picture of what's possible with this platform.
Yeah.
It starts by discussing token systems,
Right.
which, if I understand correctly, are essentially digital assets that can represent anything from a currency to a piece of art.
Exactly. And this is one of the key innovations of Ethereum.
Okay.
While Bitcoin was designed primarily as a digital currency,
Right.
Ethereum enables the creation of any kind of tokenized asset.
Okay.
You can represent anything of value on the Ethereum blockchain.
Okay. So we're not just talking about Ether, the native currency of Ethereum.
Yeah.
We're talking about a whole universe of digital assets.
Precisely. And the white paper lays out how this can be achieved with surprisingly simple code.
Wow.
It even hints at the possibility of paying transaction fees with these custom tokens,
Interesting.
which could lead to some interesting economic dynamics.
So you wouldn't necessarily need Ether to interact with certain applications on Ethereum?
In theory, yes. It all depends on how the specific token system is designed.
Okay, that opens up some interesting possibilities. What else does the white paper envision in terms of applications?
Right.
I know it mentions financial derivatives, and those sound pretty intriguing.
Financial derivatives are a way to manage risk and speculate on the future value of assets.
Okay.
The white paper gives the example of a hedging contract
Okay.
to protect against the volatility of Ether.
Right.
Let's say you're worried about the price of Ether dropping significantly.
That's a valid concern given how much cryptocurrency prices can fluctuate.
Right. So you could enter into a smart contract
Okay.
that locks in a certain exchange rate for a specific period.
Okay.
If the price of Ether drops below that agreed-upon rate, the contract automatically compensates you.
So it's like a safety net built into the system that protects you from price swings.
Precisely. And this is just one example.
Right.
The white paper suggests a whole range of financial derivatives that can be built on Ethereum,
Oh.
from options contracts to futures contracts and beyond.
Okay, so we've got hedging contracts, which sound pretty useful.
Yeah.
The white paper also talks about stable value currencies,
Right.
which I'm curious to learn more about.
Okay.
What's the concept behind those?
Stable value currencies are digital assets designed to maintain a stable price,
Okay.
typically pegged to a stable asset like the US dollar.
Right.
This is particularly relevant in the cryptocurrency space,
Yeah.
where volatility can be a major barrier to mainstream adoption.
It makes sense. If you're trying to use a cryptocurrency for everyday transactions, you don't want its value to fluctuate wildly from day to day.
Right. So stable coins, as they're often called, aim to bridge this gap by offering the benefits of blockchain technology without the price volatility.
But how do these stablecoins maintain their peg to the US dollar?
Right.
Or any other stable asset?
There are different mechanisms,
Okay.
but a common one is to back the stablecoin
Okay.
with actual reserves of the pegged asset.
Yeah.
So for every stablecoin issued, there's an equivalent amount of US dollars held in reserve.
Gotcha.
This helps to ensure that the stablecoin can always be redeemed for its pegged value.
That makes sense. But then wouldn't that require a trusted third party to manage those reserves?
It could, but the white paper explores some interesting possibilities for decentralized stablecoins.
Okay.
One concept mentioned is to use a system of over-collateralization,
Okay.
where the stablecoin is backed by a larger amount of cryptocurrency than its peg value.
So it's like having a safety cushion built in, just in case the value of the underlying cryptocurrency fluctuates.
Exactly. And this over-collateralization could be managed through smart contracts, reducing the reliance on a centralized issuer.
Okay, that's pretty clever. Now, we've talked about hedging contracts and stable value currencies.
Right.
What other financial applications does the white paper envision?
Well, it also mentions the potential for creating decentralized prediction markets.
Prediction markets, what are those?
They're essentially platforms where people can bet on the outcome of future events.
Oh, okay.
The idea is that the collective wisdom of the market can be harnessed to make accurate predictions about everything from election results to economic trends.
So it's like a way to crowdsource predictions, but with real money on the line.
Exactly. And the white paper suggests that Ethereum could provide a more transparent and secure platform for these prediction markets, potentially leading to more accurate and reliable results.
Okay, I can see how that could be really interesting.
Yeah.
And I know the white paper also dives into some non-financial applications, right? It talks about things like identity and reputation systems.
Yeah.
Those sound pretty revolutionary.
They do. The idea is to move away from centralized identity providers like Google or Facebook and create a system where individuals control their own data and reputation.
So you wouldn't need to rely on these big tech companies to verify your identity or track your online activity.
That's the goal.
Yeah.
The white paper outlines a system where your identity and reputation could be stored securely on the blockchain, giving you more control and privacy.
That sounds really empowering.
Yeah.
But how would this work in practice? How would you verify someone's identity in a decentralized system?
There are different approaches being explored.
Okay.
But one concept is to use a system of attestations.
Okay.
Imagine that instead of relying on a single company to verify your identity, you could have multiple trusted entities.
Okay.
Like universities, employers, or even other individuals vouch for you.
So it's like having a network of references that build up your reputation over time.
Exactly. And these attestations can be recorded on the blockchain, creating a tamper-proof record of your identity and credentials.
That's a really interesting concept. And the white paper mentions something called a decentralized file storage system.
Yes.
How would that work?
It's similar to existing cloud storage services, like Dropbox or Google Drive. But instead of relying on a centralized company to store your data, it would be distributed across a decentralized network of computers.
So your files would be split up and encrypted and then stored on multiple computers around the world.
Exactly. This would make it much more difficult for hackers to steal your data, as they would need to compromise multiple nodes in the network.
And it would also reduce the risk of a single company losing your data or shutting down.
Precisely. The white paper outlines how the system could be incentivized, with users paying an ether to store their data, and those who provide storage space earning rewards.
Okay, that's a really cool concept.
Yeah.
And the white paper mentions something even more ambitious. Decentralized autonomous organizations, or DAOs.
Right.
What are those?
DAOs are one of the most fascinating and potentially transformative applications of blockchain technology.
Yeah.
Imagine an organization that's run entirely by code.
Oh, wow.
Without the need for human managers or intermediaries.
So it's like a self-governing entity where the rules are encoded in smart contracts and decisions are made automatically based on predefined algorithms.
Exactly. The white paper outlines how a DAO could manage its funds, make decisions based on member votes, and even evolve over time based on predefined rules.
Wow.
It's like a new form of organization that's more transparent, efficient, and resilient than traditional hierarchies.
That sounds almost like science fiction.
It does, but the foundations are there in the Ethereum protocol.
Right.
The white paper suggests different models for DAOs, from capitalist DAOs with shares and dividends, to more egalitarian communities where every member has equal voting power.
This is mind-blowing. And those are just a few examples, right?
Right.
The white paper is packed with even more possibilities, isn't it?
It is. The white paper discusses everything from decentralized insurance platforms to online voting systems and even decentralized social media networks.
Okay, my head is spinning with all these potential applications.
Yeah.
But surely with such a revolutionary technology, there must be some challenges and concerns as well, right?
You're absolutely right. As with any groundbreaking technology, there are hurdles to overcome and potential downsides to consider. Luckily, the white paper doesn't shy away from addressing those challenges head on.
Yeah.
One of the first topics it tackles is the modified Ghost implementation.
Okay. Can you shed some light on that for us?
Sure, Ghost, which stands for Greedy Heaviest Observed Subtree.
Okay.
Is a mechanism designed to improve the security and efficiency of blockchain mining.
Okay, so not as spooky as it sounds.
No.
But what problem does it solve?
In blockchain systems like Bitcoin,
right,
if two miners find a valid block at almost the same time, only one of those blocks can be added to the main chain.
Right.
The other block becomes what's called a stale block, representing wasted effort.
Mm-hmm.
Ghost aims to reduce this waste by incorporating those stale blocks into the chain.
So it's a way to give miners credit for their work, even if they're not the absolute first to solve the puzzle.
Exactly.
Interesting.
Ethereum's modified Ghost implementation goes a step further.
Okay.
By rewarding miners for including these stale blocks, which they call uncles, in their own blocks.
Okay.
This encourages miners to collaborate and strengthens the overall security of the network.
That makes sense. It's like incentivizing cooperation rather than just pure competition.
Right.
Now, another challenge the white paper addresses is transaction fees. We talked about gas earlier and how users need to pay for gas in Ether to execute transactions in smart contracts. But doesn't this create a potential for abuse? Could miners manipulate fees or prioritize certain transactions over others?
That's a valid concern. The white paper acknowledges the possibility of what's called a tragedy of the commons scenario. Where individual miners might prioritize their own short-term profits over the long-term health and stability of the network.
So how does Ethereum try to prevent that from happening?
The white paper proposes a system of dynamic block limits that adjust based on the average gas usage over time. This helps to prevent miners from creating overly large blocks that could slow down the network or make it more expensive for users to transact.
So it's a delicate balancing act between incentivizing miners and ensuring the system remains accessible and efficient.
Precisely. And remember, one of the key features of Ethereum is its Turing-completeness. Which means you can code virtually any kind of program into a smart contract. But doesn't that open up the possibility for malicious code? Like infinite loops that could potentially crash the system?
That's a question I was wondering about as well. If you can write any kind of code, couldn't someone create a program that just runs forever? Consuming resources and disrupting the network?
Yes, that's a real risk. In computer science, there's a concept called the halting problem. Which essentially states that it's impossible to determine, in the general case, whether a given program will eventually halt or run forever.
So how does Ethereum address this problem? How do you prevent malicious or poorly written code from bringing down the entire network?
This is where the gas mechanism comes into play again. Remember, every transaction in smart contract has a predefined gas limit. If the code attempts to exceed that limit, the execution is halted, and any changes are reverted.
So it's like a built-in safety valve that prevents runaway programs from causing too much damage?
Exactly. The gas mechanism ensures that even if someone tries to write malicious code or accidentally creates an infinite loop, the system can gracefully handle it without crashing. The white paper provides several examples to illustrate how this gas mechanism protects users and the network from various types of attacks.
That's reassuring to know. Now let's talk about currency. Ethereum has its own native currency, Ether.
But the white paper proposes a rather unusual issuance model compared to Bitcoin, doesn't it?
It does. While Bitcoin has a fixed supply cap of 21 million coins, Ethereum opts for a model with a permanent linear supply growth. This means new Ether is constantly being created and added to the circulating supply.
So wouldn't that lead to inflation?
It would, but the idea is that the inflation rate will decrease over time as the total supply grows. The white paper argues that this model helps to prevent wealth concentration and ensures that future generations have a fair chance to acquire Ether.
It's an interesting approach. And definitely a departure from Bitcoin's model. It raises some intriguing questions about the long-term economics of Ethereum. Now, another concern with cryptocurrency is mining centralization. We've seen how Bitcoin mining has become dominated by large pools with specialized hardware. Does Ethereum face a similar risk?
It's a valid concern, and the white paper addresses it directly. One of the proposed solutions
is to design a mining algorithm that requires miners to access and process data from the entire Ethereum state.
Oh, wow.
This would make specialized hardware less effective.
Okay.
And encourage more decentralized participation in mining.
So it's a way to level the playing field.
Yeah.
And prevent a small number of powerful entities from gaining control of the network.
Exactly. The white paper goes into some technical detail about how this would work.
Right.
But the key takeaway is that Ethereum's design aims to promote decentralization.
Okay.
And resist the kind of mining centralization that we've seen with Bitcoin.
That's good to know. And finally, there's the issue of scalability.
Right.
As blockchain networks grow, they require more resources to store and process transactions.
Yeah.
How does Ethereum address this challenge?
The white paper acknowledges that scalability is a key challenge for any blockchain system.
Right.
And it proposes a few strategies for Ethereum.
Okay.
One idea is to use what are called intermediate state roots to simplify verification, which could reduce the amount of data that needs to be processed for each transaction.
So it's a way to make the system more efficient without sacrificing security.
Exactly. And another idea is to use challenge-response protocols to ensure data integrity. This would allow nodes to verify the validity of blocks without needing to download the entire blockchain history.
It sounds like a multi-layered approach to tackling the scalability challenge.
It is.
So after this deep dive into the Ethereum white paper, what stands out to you as the most significant takeaway?
For me, it's the sheer scope of the vision laid out in this document. It's not just a technical specification for a cryptocurrency. It's a blueprint for a decentralized future. Encompassing everything from finance and governance to identity and data storage.
Wow.
It's incredible to see how many of the ideas that seemed radical back in 2014 are now being implemented and explored in the real world.
It really is remarkable how prescient the white paper was. It predicted so many of the trends and innovations that are shaping the blockchain space today. So as we wrap up this deep dive, what's the final thought you'd like to leave our listeners with?
I'd encourage everyone to go back and read the Ethereum white paper for themselves. Even if you're not a technical expert, you'll be amazed by the depth of thought and the breadth of vision contained in this document. And as you explore the exciting world of blockchain technology, keep in mind the principles of decentralization, transparency, and innovation that are at the heart of Ethereum's design.
That's great advice. The white paper is freely available online, and it's a fascinating read even for those who are new to cryptocurrency. It's a reminder that even the most complex technologies start with a simple idea and a vision for a better future. Well, thank you so much for joining us on this deep dive into the Ethereum white paper.
Yeah, thanks for having me.
We hope you found it insightful and informative. Until next time, keep exploring, keep learning, and keep that curiosity burning bright.